In this video, we're going to work through the proof of y equal log base b of x, finding the derivative. So we're going to prove the derivative of the log of any base. To do that, we have two pieces of information given on the right. The definition of a derivative, which we'll use to do the proof, as well as the definition of e, or a form of the definition of the number e. And you might not recognize that limit. We do need it for the proof. If you haven't seen it before, that's okay. We're just going to use it once here, and we'll do a little explanation of that. The first thing we're going to do then is to plug it into the definition of a derivative. So dy by dx then is going to equal the limit as h approaches 0 of f of x plus h. So for us, that's going to be the log base b of x plus h. We replace the x with x plus h, minus log base b of just x, all over h. Now, we can use a log rule on the top. Since we have the log of two bases that are the same, then we can just combine those. So we have the limit as h approaches 0 of the log base b of x plus h divided by x. And that's all over h. Now comes the little trick. We need to somehow use the definition of e we have on the right to make this look a little different. Because don't forget, we need to get rid of that h to solve it. So we're going to take that h outside, and that leaves us log base b of x plus h over x, which we can rewrite. So we rewrote it as 1 plus h over x by dividing both parts by x. In front, we're going to have x over h because we want the exponent x over h. So the log rule lets us bring it up, but we can't just put the x there. We have to let it cancel, so that's why the 1 over x is there. We bring the 1 over x out front because it doesn't have an h in it. It doesn't affect the limit. Inside the limit, then, we're left with the log base b of 1 plus h over x all to the power of x over h, because the term in front can become an exponent, again from the log rules. That is the e that we see on our right-hand definition we started with, so we're left with 1 over x times the log base b of e. And that is the derivative of log base b of x. Not the normal way we'd write it, though. We want to change the log base b of e. So using log rules again, log base b of e is the same as 1 over the natural log of the base, which is b. And so just to summarize then, we've now proven that given y equals the log base b of x, the derivative then is 1 over x times the natural log of the base.